So yet another form is the general form. So basically we're saying every line is the graph of an equation of the form ax plus by equals c. All right, so in this one, we're not really representing it with the y on one side and the x on the other. We're putting the x and y on one side and saying that ax plus by equals some constant c. Now, some people may move the constant over to the left and do something like ax plus by minus c equals 0, but it's not really that important. They're really the general form either way. And we can't have both a and b be 0 here. We'll see that in a minute. Okay, so this is a nice form of a line, as we're going to see later on when we talk systems of equations. It's often used there, and it's used in other places as well. It's not the form we're going to use most often, but it is a very nice form. So let's take the line we found above, negative 1/3 x plus 1, and put it in general form. So the way we're going to do that, let me write my y equals negative 1/3 x plus 1. All right, so basically the idea is I want to get rid of the fractions and then move the x's and y's to one side. So the easiest way to get rid of the fraction in there, is to multiply through by the least common denominator, which is 3 in this case. So I'm actually going to multiply both sides by 3. If I do that, I get 3y is, 3's cancel there, so I get negative x, and then distribute, remember, the 3, so I get plus 3. So I have 3y equals negative x plus 3, and then I'd simply add the x to the left, x plus 3y equals 3. And there you go. There's the general form version of that line. And the nice thing here is I can represent this line without any fractions here, just as integer multiples of x and y equal to some integer constant. So that's a nice aspect there. That doesn't always have to be integers. I could have irrational numbers in here as well, but we'll mostly use integer, put lines in which we could represent these with integer coefficients. All right, so the question is, we said a and b can't both be 0. Well, that makes sense, because if I had a and b both be 0, then the left-hand side would be 0, and the only thing on the right-hand side, c, could be 0, so very limiting. But what happens if either a is 0 or b is 0? One of them is 0. Well, in that, those are the cases where we get horizontal and vertical lines. So let's see how exactly that happens. Okay. So remember from before when we were talking slope, a horizontal line has a slope of 0. And so it's going to end up just being y equals some constant k. So what would that look like? That would just be a horizontal line at some k value on y. So that's y equals some constant k. All right, again, x can be any value, but y is fixed at k. For instance, if we talked y equals 2, we'd be looking 1, 2, the line right there of y equals 2. So that would be the line y equals 2. X can be anything, but y is 2. We could be talking y equals negative 5/2. All right, that would also be, well, now in this case, negative 5/2 is 1, 2, 3. That's negative 2.5. So let me use another color here. So that would be negative 2.5 right there. And there we go. there is y equals negative 5/2. So now, what about a vertical line? Well, vertical lines, as we saw before, meant the slope was undefined. That was x is always the same number, x is a constant. So a vertical line would look like this, where we'd just be saying x is the same constant k. For example, x equals 4. 1, 2, 3, 4 in x. So we'd be right there. And then we're always at x equals 4. Y can be anything. Sorry. Or with x equals negative 3, negative 1, negative 2, negative 3. So we're fixed at x equals negative 3, and again, y can be anything. So remember, y equals a constant is a horizontal line, while x equals a constant is a vertical line. So now let's think about if we had two lines, how they could be configured. Now, two possibilities are that we could have them parallel or perpendicular. They don't have to be parallel or perpendicular, but these are two really important configurations. So, parallel lines. Okay, two lines are parallel if they have the same slope. Okay, so that's all we need to do. Let's say if we wanted to check that two lines are parallel. All right, so show that the two lines y equals 3x minus 5 and 9x minus 3y equals 8 are parallel. Okay, well that's not too difficult. All I have to do is talk slopes. So let's call this one line 1 and this one line 2. Okay, so line 1, I'll say its slope is m1, and that's going to be simply 3. I can see that because it's in a slope-intercept form, and I can pick right out there. Now the second line is not in slope-intercept form, so I'm going to have to put it in it. Negative 3y equals negative 9x plus 8. Divide through my negative 3. And I'll get y is 3x minus 8/3. And now I can see that m2, the slope of the second line, is also 3. So m1 equals m2 is 3. These lines are parallel. So what about perpendicular? Well, two lines are perpendicular if the product of their slopes is negative 1. Now this is one way to characterize it. You're probably more familiar with another way of saying it, is that one slope, the slope of the one of the lines, is the negative reciprocal of the other. Okay, so in the first way, if we're talking about, basically we're talking about some m1 times m2 is negative 1. In the other way is just talking about it as m2 is negative 1 over m1, which is actually the negative reciprocal. So negative, and then we're going to flip the m1 slope. Okay, so if we wanted to show that two lines are perpendicular, we'd have to show that this relationship exists. So we would do something like, okay, the first one, again, let's call this one line 1 and this one line 2. All right. And the first one definitely has a slope of 2. Again, easy because it's in slope-intercept form. Oh, the second one is actually also in slope-intercept, and I can pick out that m2 is negative 1/2. All right, so I actually can see right here that negative 1/2 is the negative reciprocal, because if you take 2 make it negative and flip it, you get negative 1/2. Or if I want to see the other way, I can see that m1, m2, if I multiply them, 2 times negative 1/2 is negative 1. And I see that these are indeed perpendicular. So I have the perpendicular lines in this case.